Rightio, this one's a wee bit nicer in some ways, in that they've actually given you the formula for our nth term rather, nth term. So our nth term is just n plus 1 over n to the power of n, and then our n plus 1th term, wherever you see an n, replace it by n plus 1, which is going to get a little bit messy, but that's not too bad. And we can simplify that down a tiny amount by adding up that top line, and on the bottom really it's just a multiplication and a power, so we'll go with that. And then we're going to do our ratio, so n plus 1 over nth terms. So our n plus 1th term is n plus 2 over n plus 1 to the power of n plus 1 times the inverse of our un term, so we're dividing by un, so it's same as multiplying by its inverse. Okay, and we end up with something which looks like this. And then we have the same routine as we had in the previous one. This one and this one can go out just to leave a 2. So we end up with, on the top line, n plus 2, and on the bottom line, 2n plus 1, n plus 1. Okay, and then I probably want to expand those brackets out, so we get n squared plus 2n, on the bottom 2n squared, because it's n squared doubled, and we have 2n doubled to be 4n, plus 1 doubled is 2. And so we'd end up with an expression that looked like this, and we're trying to find what happens as n gets really, really big. So just the same as we did last time, limit as n goes to infinity of the n plus 1th term over the nth term is the limit as n goes to infinity of n squared plus 2n over 2n squared plus 4n plus 2. And I'm going to pull exactly the same stunt as I did last time. Just divide everything through, not this time by n, but by n squared. So if I divide everything through by n squared, basically that's the biggest order. So that gives us 1 plus 2 over n, and on the bottom 2 plus 4 over n plus 2 over n squared. And as n towards infinity, these things clearly head to 0, 0, and that one heads to 0 double fast. So all we're left with is a half, regardless of what n is. So that's going to be a half. So as previously, the limit as n goes to infinity of the ratio, in this case equals a half, which is less than 1, and so we conclude that the series converges. Okay, so it's a fairly standard process. Write an equation for your nth term, increment it to the nth plus 1th term, form a ratio, bit of simplification, and let n go to infinity and see what the answer is. And then if it's less than 1, it converges. If it's greater than 1, it diverges. And if it equals 1, you still don't know what's going on.